Rectangular concrete beam of width B equals 600 mm is limited by architectural considerations to a maximum depth H equals 400 mm. It must carry a total factored moment M sub U equals 540 kilonewton meter. Allow 75 mm cover to center of bars from the face of the beam. Use Fc prime equals 28 megapascal and Fy equals 420 megapascal. Use strain equals 0.005 for max steel ratio. Determine the following. What is the required compression reinforcement of the beam? So as you can see, we have here a dimensions, but we do not have a steel reinforcement. The given is the factored moment to be resisted. So this problem is a design problem because we are going to determine the amount of the reinforcement that will enable our beam to resist this factored moment. Okay, so first we have to check on what kind of beam are we going to use. Are we going to use a singly reinforced concrete beam or are we going to use a doubly reinforced concrete beam? So in order to determine that, we have to compute first the capacity of our beam considering the maximum steel ratio allowed for a singly reinforced beam. Okay, because if the singly reinforced section can no longer resist the moment, that is the time wherein we are going to use a doubly reinforced section. So first we have to compute for the effective depth. So that is 400 minus the effective cover. After that, so let us compute the depth of the neutral axis C. So as you can see, it is stated in the problem that we will use the strain of 0.005 for max steel ratio. So we equate this to 0.005, then we can compute for the value of C. The value of C is 121.875 millimeters. So with that, we can now compute A, that is 0.85 of C, and that is 103.59375 millimeters. Next, C equals T. So we have 0.85 FC prime AB equals ASFY. So take note, we already have the value of Y. That's why we already proceed with the equilibrium equation of C equals T because we are going to calculate the moment capacity considering that C. So 0.85 FC prime AB equals ASFY. So we have 0.85 FC prime 600 times A equals AS max. So we can now compute for the AS max and that is 3522. So now that we have AS max, we can now compute for the nominal moment strength considering this amount of reinforcement. Compute natin yung moment that corresponds to the maximum steel ratio. Kumbaga, ano daw yung pinakamalakas na moment na kayang buhatin ng singly reinforced lang. We substitute in our formula of Mn, which is ASFY D minus 0.5A. Okay, so we substitute sa formula natin yung AS. And then Fy is 420. And then D minus 0.5A. Ayan, substitute natin. So therefore, we have Mn equals 404. So in kilonewton meter, that is 404.15. EMN equals 0.9 times 404.1545054. Okay. So as you can see, we no longer check the value of reduction factor. We just directly proceeded to a value of 0.9. That is because our strain is 0.005. Recall that if we have a strain of 0.005, the automatic value of the reduction factor is 0.9 if the strain is 0.005. That is why we proceeded already that the reduction factor is 0.9. So therefore, the value of the moment capacity is 363.7390548 kilonewton meter. So as you can see, this is the maximum moment that can be resisted by a single reinforced section. And take note, the factored moment that needs to be resisted in the problem is 540. So it means that it is not enough to use a single reinforce. Kasi ang kaya lang ng single reinforce ay 363. Ang kailangang buhatin na moment ay 540. So it means that we have to use a doubly reinforced section. The excess moment will be carried by the compression reinforcement. Okay? So yung kulang dito sa 540, yun ngayon yung bubuhati ng compression reinforcement. Okay? So what is the required compression reinforcement of the beam? So we can now solve this. PMN1, ito yung na-compute nating moment capacity na kaya ng single reinforced section. And then MN2 is the moment capacity that will be resisted by our compression reinforcement. Okay? So we have 0.9 AS prime times FS times D minus D prime. Dinivide ko to ng 10 to the 6 kasi ang lalabas na unit nito ay Newton millimeter. So I have divided it by 10 to the 6 so that the units will be kilonewton meter. So equate natin yan sa 540. Let's compute for Fs. That is 600 times C minus D prime equals C. So we have 600 C minus 75 over C. So Fs is 230.769 megapascal. So kaya nilagay ko na agad dito Fs. So actually, di ba dapat Fy? Pero since may value na kasi tayo ng C, pwede na natin agad ma-check kung mag-yield ba yung compression steel or not. So since it does not yield, so nilagay ko na agad na Fs. Okay? We can now compute for AS prime. AS prime equals 3394.655. Okay, and that is letter D. Next, what is the required tension reinforcement? Okay, tinatanong tayo ng required tension reinforcement, no? Kanina, meron tayong na-compute na tension reinforcement. Ito, no? Yung galing sa AS Max, 3522. Itong na-compute natin, yan yung value ng reinforcement na maximum if singly reinforced. Kaso, ginawa na natin siyang double reinforced, no? So, kailangan may magbalanse nung dinagdag mong compression reinforcement. So, ibig sabihin, itong AS max na to, mababago na to kasi double reinforced ka na. We have to use again yung equilibrium equation natin na C equals T. So, yung lahat ng elements mo sa compression, that is 0.85 FC prime AB plus AS prime FS, i-equate lang natin ngayon sa AS FY. So, we already have values of A, 103, na-complete na natin yan before. And then yung AS prime, we have already computed this from the previous problem. And then Fs, we also computed this already. And then this is equal to AS times Fy. Okay, so we can now compute for the required value of AS. We have 5387.38. Okay, and that is letter A.